All right, welcome to another IAEI News Live. My name is Thomas Dimitrovich, and today we're going to be talking about terminations. We're going to be talking about landing wires on terminals and the details around how maybe that's not as simple as we thought it was. And we're going to start that discussion now. All right. Okay. Well, welcome to another. Today's Tuesday. It's Tech Tuesday. It is IAEI News Live Tuesday, and we are talking terminations. I sent that notice out to everybody, and Felix Sandoval, good morning. Thanks for joining us. So I sent that notice, Larry, out to say, hey, I'm talking about terminations. And they said, I had some people come back and say, hey, where are you moving to? And I'm like, no, I'm not getting terminated. I'm talking about terminations, right, Larry? Mr. Griffith in the house. All right, so we're talking terminations today, and I like to talk about, I'll give you a little bit of the background around this discussion today. There was a gentleman, Alabama, Donnie Cook, who asked me to come down and do a 2-hour program on terminations, Mr. Wages. And I said, Donnie, 2 hours on terminations? How could I possibly do 2 hours on terminations? I mean, you put a wire on a lug and you screw it down. So he said, just I'll get you the questions and you come on down, and I'll tell you what, Lou Petrucci, thanks for showing up. We didn't have enough time to go over terminations. So I'm going to just try to get through this. Mr. Vince, good day from cold Colorado. Hopefully it's not snowing in Colorado. I heard it's sunny, and I heard that you guys are sunbathing out there at this time of year. All right, so let's talk terminations. See how we do. Let's see how we can make this happen. All right, so terminations. Okay. Why do we care about terminations? It's a process, right? Terminating a conductor under a lug, around a post, whatever we're going to be terminating, whether it be a pressure fitting, whatever it is, there's a method to it. There are details that you need to think about, and we should always be following manufacturer's instructions, right? Michael Hofkin in the house. We're talking terminations, brother. So, and a great reference. Now, again, my reference today is going to be the 2020 National Electrical Code, which my copy has got some issues. And I don't know if Jeff Sargent is out there, but look what happened to my book. I mean, it's a mess. It's a mess. So 110.14 is a place that we're going to look at, but it's not the only spot in the code that we need to think about. And we're going to talk and walk through a lot of these. Why do we care? The lugs that we're using, the size of the wire that goes under in that lug, what is permitted. There is a minimum and a maximum. Okay. We have to make sure that we're got the right lug for the environment. B, that we're using the right size conductors for that termination. Joe Bellantoni, thank you for joining us. This is an interesting one here. When you look at this connection, you see a lot of different. There's stranded conductors under a lug, and I think a lot of people just think, hey, I have a place to put a wire. I'm just going to stick it in there, and we're going to see how this flies. And sometimes that's not the right process. And this is an example of what can result. What we can generate if we don't terminate conductors correctly And Jody, that's why you take the book to Staples and have it spiral bound. It keeps that sort of thing from happening. You know what, Jody? You're right. I should have. And I was thinking about it, but I think it's too late now. I think I'm beyond the point of no return. And it's my only 2020 code book. I usually have like 2 or 3 editions of the same edition, but this is my only one. So my book's looking like this. I didn't terminate it correctly. Heat can be generated at the termination point, and that heat may take a long time to reveal itself. Okay. And now I'll tell you, I wish, and I was looking for it and I cannot find it. I don't know where it's at. I got a big bin of product back there. I checked behind me and on my bookshelves. I've looked everywhere for it. But I had one specific receptacle that was sent to me and I've kept it, and I still have the letter that was written, and I keep it with it. So that's why I'm thinking it's in my office at the office. But in that case, it was one of our Eaton employees who was moving. And he tried to move his refrigerator that was located in his garage. He tried to remove the refrigerator and unplug it, and he could not unplug it. And what he mailed to me, and unfortunately I get a lot of these types of things mailed to me, but he mailed me his receptacle where the plug was just melted into the receptacle. And that was because of the amount of heat. And it had been that way for a very long time. So your termination points, which in many cases, we don't put the most experienced person on the job in terminating all of the receptacles in a structure. I don't care if it's a residential or a commercial building. A lot of times, all too often, it's not the most experienced individual who is performing those terminations. But I'll tell you, that is a very critical piece of the installation. Your termination makes a big difference. And then you'll get things like this one, right? Where you've got a lot of stuff going on here, putting too many conductors under a lug, putting conductors that are of the different sizes, right? If I put a very small conductor under the same termination with a very large conductor, you're not going to get good connection. That small conductor may not even get any pressure associated with it, any connection. Hey, Tom, hey, Willie Snyder, good. Thanks for joining us. So terminations are a very important part of the of an installation. And here's another example. Again, you take an example like this. This would probably be on the external of a home. It's a meter socket, and that could be a combination of lack of proper torque. It could be a combination of just deterioration of the lugs, which brings me to another point that you've got to think about maintenance. And when you are conducting maintenance in a power distribution system, and what document comes to my mind is 70B, and that's going through a change right now. And hopefully everybody out there is engaged with what's going on in 70B. It's becoming a standard. But these types of termination points, these are the things we need to be constantly looking for, because even though you think you did a great job, you need to be following up. And what's one of the key methods of identifying a bad termination? Infrared IR scanning, right? And that is a part of, that is like, if you look at 70B, IR scanning, it's not on a, they don't highlight IR scanning on a product by product basis. They tell you, you need to IR scan all your terminations, all your equipment, period, on a scheduled basis. And you'll find stuff like this before it becomes a problem. Will Sinclair from Cape and Islands chapter. Thank you. Supercode. I can't wait for Supercode. Oh my gosh, I can't wait for Supercode. I got to book my room though. Will, I've got to get my room booked. So if you're not, and I tell you what, those guys up there in the Cape and the Cape and Islands chapter, they do a great job in talking about the latest and greatest in the code. And I believe your state is one of the first to adopt the National Electrical Code. So kudos to you. All right, 70, 90.3. These are all the different sections we need to think about in the code. It's not just a 110.14. You got 110.3b, installation and use. Why is that important? Because the manufacturer is going to tell you what the term, look at that. I got an orange part. I got to take that off. The manufacturer is going to tell you what torque and how many conductors can go under a lug. They're going to tell you what size conductors can go under that lug. They're going to tell you a minimum and a maximum. You got to read the manufacturer's instructions. 110.11, deteriorating agents. 110.11, I know you got your book open. This is identified for use for the environment. So if you've got terminations in and around swimming pool equipment, in caustic areas, in damp areas, wet location areas, I don't care if it's an area that is outside of an air-conditioned room, you're going to have to pay special attention to the listing of the termination. What are you applying? How is it listed? To what standards is it listed to? What does the manufacturer tell you? I don't know what that was. You got like a little hair floating around. So deteriorating agents are very important parts because, if you think about these applications, we will have terminations in certain environments that you've got to be thinking about what they're going to be exposed to. The equipment too, in general. 707 public, 707 public inputs. Yes. People are putting in their input. Yes, excellent. All right. So 110.12, integrity of electrical equipment and connections. So 110.12, and I specifically called out B. A is unused openings. C is a new section within the 2020 code called cables and conductors. And it just talks about where they're exposed. So I'm just looking to make sure. So B is integrity of electrical equipment and connections. Another important section for you to understand every time you land a conductor on a lug, on a terminal. It's, like I said, Donnie Cook told me, hey, I need you to come down and do 2 hours on terminations. And I said, 2 hours? I said, we can do a demonstration. And he's laughed. He says, don't worry. And I'm telling you, we didn't have enough time. Now, I know Michael Hofkin, you are going to be out there going, what's he talking about the white book for? Michael, I need you to put a link in the chat if you can, or just tell us, what's the new name again for the white book? There's a new name. It's code something. But anyway, there are categories, UL categories that address connections. AALZ, electrical equipment for use in ordinary locations. ZMOW, don't try to say them, just spell them. Wire connector adapters. Then there's wire connectors and soldering lugs. There's sealed wire connector systems. Follow the manufacturer's instructions. These are all references for you. Hey, Joseph Violi, thanks for joining. Also, UL standards, wire connectors, 486A and B. 486A is wire connectors and soldering lugs for use with copper conductors. B is wire connectors for use with aluminum conductors. And then you got splicing wire connectors, sealed wire connector systems. And then you've got equipment wire terminals for use with aluminum and or copper conductors. There's another dynamic to landing a terminal. Landing a wire on a termination. Is it a copper conductor? Is it an aluminum conductor? Is it a stranded conductor? Is it finely stranded? Can the lug accommodate that? How many conductors can I put on that termination? It's not as simple as you really think when you think about landing a wire. And what do? We give that to an apprentice. we give that to the probably sometimes the most inexperienced person on the job site, but they don't, I don't think, quite grasp the magnitude and the importance of the task that they are performing. Terminating a conductor is a critical piece from an electrical safety perspective for the installation. UL, Chris Follen, thank you. UL Product IQ. That's that. So if you go to the web, search for Product IQ, UL Product IQ, you're going to find all of the resources. You'll even find marking guides for conductors, for breakers, and all of that good stuff. So your conductors are an integral part of that termination. Remember, there's two ends to every conductor. And I say that for a couple reasons. One is the termination, but the other area that we always got to remember, there's two ends to the termination, is when we're doing our ampacity calculations, our conductor ampacity. If we don't understand the fact that your limiting factor for determining the ampacity of a conductor might not be where you're landing on one end, it might be at the other end. For example, if I might have a 90 C piece of equipment on one end, the lug is rated for 90 C, the equipment is rated for 90 C, but on the other end, I'm landing it on a circuit breaker and it's 75 C, I have limited my ampacity for that conductor to the 75 C column, not the 90 C column. So you've got to understand your terminals. You've got to understand that there are two ends to every conductor. And you got to land them both the right way, right? We have copper clad aluminum, and we have aluminum. And copper clad aluminum, if you're not familiar with the 2023 process, there was a lot of activity around copper clad aluminum. I'm not sure how much of that actually stayed in the National Electrical Code. There is existing recognition for copper clad aluminum, and they're seeking to expand that. And it's really important that we understand what copper clad aluminum is, what aluminum is, what copper is, and how do they relate with each other, right? Do they play well in the same sandbox? So you've got stranded copper conductors. And again, the purity of the conductor, of the copper that's used in there. So Joe Bellantoni says on YouTube here, sometimes the licensed guy assigning the task to the apprentice does not understand the importance of the task of termination. You're absolutely right, Joseph. I agree with you 100%. And I think that's why I think this short 1 hour program is something that we're going to build off of, and I think we need to build off of as an industry. That when you tell an individual your job is to land all the conductors on every receptacle in this structure, they may look at it as I got the dirty end of this stick, and I've got to who wants to do terminations? But they have to understand the importance of that, and that's really an important job. Copper clad aluminum consists of copper cladding surrounding an aluminum core. And I'll tell you what, I learned a lot just this last cycle from the folks who are educating and helping us expand in the National Electrical Code the use of copper clad aluminum. This conductor is, that copper is not like you can separate it. It is one and the same. They make a large bar and then it's extruded down, and it's not put on after the fact. It's all a part of the process. I tell you what, it is fascinating. And I know there are videos out there online, and maybe I'll try to get one of the copper clad aluminum guys to come in for a discussion on this. But I tell you what, that the process and the materials and the details around copper clad aluminum, I've grown my knowledge over the past 3 years just because of the code process. And maybe we'll try to do that with all of you as well. And they have to meet strict rules and from a standards perspective. Aluminum conductors, they've been and recognized in the National Electrical Code since the second edition of the NEC. Since 1901, we have recognized the use of aluminum conductors. Very successfully utilized in the electrical industry. Now, aluminum conductors got a bad name, and if you're I believe it was the 70s, and I've got some slides on that. Aluminum conductors did have some rocky roads in there, but specific examples, and we'll talk about that. But we use aluminum a lot from a conductor perspective. From in equipment, you'll see aluminum bus bars and things of that nature. Very healthy product. Very heavily used. It is now when you see stuff like this, you say, "Well, that's ungood, right?" I mean, this solid aluminum conductors, these right here, those are solid aluminum conductors. And between 65 and 1973, those single-stranded aluminum wire could be installed in residential homes, but they had electrical fires, and there was a problem. It was the type of aluminum that they used. They don't use it anymore. All right, Chris, thanks for letting me know. I'm going to have to beat up Joe Pavia for his presentation on copper-clad aluminum. Thanks, Chris Clancy Cleveland. The 3 C's, and today is the 4 2s. It's the 2nd. It's the 22nd of the month. It's the 22nd day, and it's the 22nd year. So it's 1, 2, 3, 4, 5 2s. All right. So we always think about those aluminum alloys, and in my opinion, that gave aluminum a little bit of a bad name. But it was, I think that what I've learned in their electrical industry, we've got great memories. Oh boy, we can remember the old, the old whatevers. You know what I'm saying? It takes that one oh crap moment, and then we remember that forever. And I think there are still a lot of people that have a misconception about aluminum conductors because of that, and the issue that was going on through 65 in the 70s, from 1965 through the mid 70s, the 15 to 20 amp circuits, the volatility in copper drove the aluminum solution, and they used a solution that was I forget the type. There it is. Solid aluminum conductors shall be made of an AA8000 series electrical grade aluminum alloy conductor material. And that was introduced in 87. And in 81, they introduced 310.14 solid aluminum conductors number 8, 10, and 12 shall be made of an aluminum alloy conductor material. And then they added an informational note to tell you exactly what we're talking about there. But they realized it was the material that they were using. So, and here's some of the language. So this was Peter Pollack, the Aluminum Association brought this to the forward. They added the aluminum conductor material, solid aluminum conductors, numbers 8, 10, and 12 shall be made of an aluminum alloy material. It was unanimously affirmed. This is the 1981. And again, his substantiation to provide recognition of proper conductor material for solid numbers 8, 10, and 12 aluminum. And they talk about, if you go back and you can get all of this online for free from the NFPA. Peter Grazier, that's right, Peter Grazier. That's what I was wondering. Joe Pavia, wow. Peter Grazier. Now, I'll tell you what, I'm going to make a note. I need to get Peter Grazier on this, on the IAEI News Live. I will reach out to Peter. Thank you, Chris. Appreciate that. All right. So then over 95% of all strand aluminum conductors supplied as XHHW, THWT are produced with 8000 series. And this is when they added the note, revised that note to read AA8000 series aluminum alloy conductor. So they fixed that. Historically, aluminum building wire manufactured in 1350 EC aluminum alloy exhibited poor termination. So that's the number I was thinking of. 1350 is the number. You can always pause this and read it later, but I'm gonna blow through that. This is just from the 1987. This is the substantiation for adding that informational note about AA8000 series, the materials for the wires. All right, so 110.14. Let's take a look at 110.14 together, because we can. Together, so 110.14, because of different characteristics of dissimilar metals, Devices such as pressure terminal or pressure splicing connectors and soldering lugs shall be identified for the material of the conductor and shall be properly installed and used. So material of the conductor makes a difference, and you identify the terminations, the terminals, with what they can accept, what they're rated for, what they've been tested for. Conductors of dissimilar metals shall not be intermixed in a terminal or splicing connector where physical contact occurs between dissimilar conductors, such as copper and aluminum, or aluminum and copper clad aluminum. Because remember, copper clad aluminum has aluminum on the outside. It has copper on the outside. This is moving faster than this. Remember, question everything you hear and always question everything you see. All right? So, and unless the device is identified for the purpose and conditions of use. So what we know is, we know that terminations are going to be for specific conductors, and we know that there can be an identified, they may be tested and listed. And where are we going to find that? In the manufacturer's instructions. Don't you love it when a plan comes together? Materials such as solder, fluxes, inhibitors, and compounds, where employed, shall be suitable for the use and shall be of a type that will not adversely affect the conductor's installation or equipment. Well, duh, right? Yeah, you don't want to adversely impact. You don't want to squeeze anything on there like ketchup or something. No, it's got to be listed for the application. And if you use ketchup, make sure it's Heinz. Okay? That's the only ketchup to use. I'm just telling you, this is what I use. All right? And it's from Pittsburgh. Connectors and terminals for conductors more finely stranded than Class B, more finely stranded than Class B and Class C stranding tables shall be identified for the specific conductor or class or classes. That's another, that was, I forget what year that came into the code. I might have that in this presentation. Well, when that hit the streets, finely stranded, finding lugs and terminations that can be used with fine stranded conductors could be a challenge. And then what do? I have a fine stranded conductor. Fine stranded conductor, why are they nice? That's that welding cable, very flexible. I mean, I believe like these, I have my phone plugged in, and some of these conductors are real, like the stuff I get from one manufacturer of phone. It's like they're very flexible, more flexible than others. I think it's the stranding in the conductor. I don't know. I just work here. You see this picture here? I took that photo, building wire that wasn't an alloy. Yeah, look at this. So this termination, I'll tell you the story behind this. I went with an inspector on the roof of a photovoltaic installation. It was beautiful. When I looked at the top of that roof, I was just amazed. I mean, it was, all of those panels were nice. The color was a good, sunny day. And I have all of those pictures a part of my PV presentation. Well, I'll tell you what, I looked at everything, and the inspector turned around and looked at me and he says, put your hands in your pocket and don't touch anything. I was like, okay. I said, well, treat me like a little kid. That's okay. I mean, I get it. So I put my hands in my pocket. And he says, I'm going to show you issues. And there were so many issues with that installation on grounding and bonding. And this terminal, this lug was not the right lug to use. It was interacting with the aluminum on the structure. And there were many issues with grounding and bonding, or with bonding on that PV application. Well beyond even this one, but you really had to look up close, and you have to think about things like oxidation, corrosion, thermal linear expansion of coefficient, and creep. Not creep, but creep. It's the deformation of material, right? So aluminum quickly develops a layer of oxide when exposed to air, which is highly resistive. Corrosion occurs when aluminum conductors due to galvanic action, and that's when you have the dissimilar metals. That termination, that connection point was not looking good. And as we walked through that entire installation, I was amazed. I was amazed at what that looked like. And I'm looking back, because I have White Book again, and I remember UL Product IQ. So I have a White Book, but the White Book was replaced by Product IQ. These are some of the identifications, some of the, what do they call that, category codes, UL Product category codes. ZMKQ is crimp tool, classified for use with specific wire connectors. ZMNA, multi-pole splicing wire connectors. These are, so what all of the information that is available by knowing those category codes helps us understand how to properly apply the products. A lot of what you read there should be in the manufacturer's instructions, but it's still, it's a wealth of information. So, and there's, you're looking for the markings, whether it's CU for copper, AL for aluminum, ALCU, CUAL. ALCU is intermixed dry locations. You're looking for the markings on those. Oxidation, corrosion, conductors of dissimilar metals shall not be intermixed. When you intermix and you make when you intermix those types of dissimilar metals and whatnot, there's a lot of problems that can arise. I went the wrong way. Glowing contacts. Okay, glowing contacts. Loose connections, they develop into a glowing contact. What is a glowing contact? Will an AFCI detect a glowing contact? Will a GFCI detect a glowing contact? Answer to both of those questions is no. There's no test for a glowing connection. And I'll tell you why. The glowing connection is one that is, how do I explain it? It's when you get the terminal, Jody, Crystal Hunter's a great reference for conductor types and terminations from Sarah. When you get a conductor under a lug, under a termination, and it's not torqued correctly, and they're just touching each other, so to speak, you'll get a transfer of current, and it will create heat that eventually melds the two materials together, and they glow. And they're going to result in a fire. It's just a matter of when, and it could take years. The case of that cord on the refrigerator from that one employee that sent me that receptacle where the cord was melded into the receptacle, melted. It was hot when he took it out. It didn't start an immediate fire. Why? Because the materials around it were just drying out. And this is the story of ASCIs. This is what happens when you have that conductor behind the wall. It dries all the materials around it until it becomes flammable, and you have that temperature point that is high enough to ignite the materials. If you have drapes around it, all that jazz. I've got a video to help you understand the glowing contact connection. So this is 25 times real time. You'll notice that that is just melting the receptacle all the ways around it. It's sitting there glowing. A GFCI is not going to recognize this because everything is staying in the circuit. An AFCI is not going to recognize it because there's no arcing and sparking going on. This is a hot spot. It's a glowing connection that those conductors are just touching. That lug, that screw was not screwed down, and it will create enough heat. The plastic will melt. And in the case of the receptacle that was sent to me, the plastic melted, and it melted the cord, was melted into the receptacle. Torque plays an important role to make sure that you don't have this happen in a structure. This is why the job of the person, the individual, whose job it is to install a receptacle, may think it's that they were low person on the totem pole when that job was given out, and that it's not important. It is very important to make sure that you do this right, because long after you're off that job site, when that house burns down eventually, this could have been the culprit, and it may have taken years, could have taken months, could have taken weeks for this to manifest itself and be more drastic than just melting the receptacle. This was taken off of a photovoltaic system. These are those, I call them tip-ups. I don't know what you call them. They put the fuses in there. If you don't push those in all the way, you can create a hotspot. Larry Griffith, most devices used in the 70s and 80s were rated only for copper. Correct. When connected to aluminum type NM, many devices became in-the-wall heaters. Yeah, what a way to heat the house. Don't want to do that. That's what we call ungood. Now, you take a look at some equipment gets exposure to bad environments. And I don't care how you list the product. I don't care how you test the product. It could be the best doggone product in the world. You put it in a bad environment and bad stuff is going to happen, right? You misapply a product. You misapply any types of solutions. You could, and I'm going to say it could achieve an unintended rapid disassembly in the field, because anything will fail when you mistreat it, including me. All right, UL 486A, B terminal markings, right? Talks about connection for copper conductor shall be legibly marked with CU on the connector, its unit container, or an information sheet packed in the unit container. So most of the stuff that I have in front of me, like I have a receptacle here. I've got a receptacle and it says CU for copper and it's got a sticker over it and I can't read it. Ungood connections will cause URDITF, unintended rapid disassembly in the field. Felix Sandoval, you get it. So this one here has a circle and a CU and a circle and an AL. But the circle in the AL has a line through it. So no aluminum. That's this. I'm going to take a look at this. This is a fuse block. It says, what does it say? It says, what does it say? I see the size of conductor. I see a 1 to 3, number 3, 4 to number 6, 8, 10 to 14. Tells you the torque, 75 degree C wire. But it doesn't have the material. The material will probably be in the instruction leaflet, because the standards, the terminal markings let you do that. You may find a terminal in the field that has no markings. My point is, find the manufacturer's instructions. It's going to be in there. So this is the front of a breaker, circuit breaker, right? So you have, this is showing you copper, CU/aluminum, switch device, hacker, rated. So the equipment is going to give you the information. This was right out of Home Depot, Lowe's, I don't know where we were at. Actually, I think that's Donnie's. UL 20 amp tells you number 14 to number 22 copper. So that specifically says CU. And that says copper. So this one here is specifically, and that's just a terminal strip. But I'll bet you take that terminal strip out of that package and it's not on that terminal strip. You know where it's at? Right here in the instructions. And you know where that ends up? In the dumpster. You got it. So dumpster diving is a sport. Dumpster diving, we have dumpster diving competitions at IAEI section meetings every now and then. If you're lucky to come to an IAEI section meeting where we have the dumpster diving Olympics, which is a word, Olympics, games. Olympics is a trademarked word. I don't know. I can't write it. Probably can't say it. Panel boards. Look what it says in panel boards. Panel boards. If any terminal of the panel board is marked to indicate that aluminum wire may be used at the terminal, such as by being marked with the symbol AL, and if such marking is visible under the conditions described, the panel board shall be marked in accordance with whichever applies. And look what it says here. If, because of wire space or other factors, a terminal of the panel board is not acceptable for use with aluminum wire, the panel board shall be marked, use copper wire only. If a panel board is acceptable for aluminum wire only, the panel board shall be marked, use aluminum wire only. There are marking requirements in each of these standards. Look at this. If the wiring space and other factors are such that all terminals of the panel board are acceptable for use for aluminum and copper, you use copper or aluminum. So read the labels. I know it's hard. I know it's difficult sometimes, and it can be emotional, but read the label. Okay, RTL. Read the label. It's like Anna Marie Albagheti, the Good Seasons lady. It's in there. So look at this. Panel boards. Then you have ALCU, CUAL, see you later, or equivalent. Any abbreviation designated copper and aluminum shall be. Here we go. There we go. Now we're going to get... look what it says here. This is from a panel board. Terminals other than breaker terminals suitable for 60, 75 degrees C ALCU. Right there. Look at that. Huh? Suitable for ALCU when so marked. Refer to markings on breakers. And look what it says here. Wire size cable, 60, 75 degrees C, ALCU. 110.14 says materials such as solder, fluxes, inhibitors, and compounds where employed shall be suitable for the use and shall be of a type that will not adversely affect the conductor's installation or equipment. So I know we use, and I don't mean to throw a brand up there, but I'm throwing a brand up there. I mean, it can be anybody's. I'm trying to get me out of here. How do I get me out of here? Oh, right there. Right. So connectors, spliced, ideal. This is NOx. You've all heard NOx, right? This is your B oxide inhibiting compounds. I don't know if I'm using trade names or what I'm using, but you've got to read the connector manufacturer's instructions, and then some instructions will tell you to use this. And quite frankly, what I would do is follow manufacturer's instructions on how to apply it. Sometimes too much is ungood as well. Read the installation instructions. Yep, from the manufacturer. All right, so ASTM B8 through 11. Hey, Lou, don't leave us, brother. Don't leave us. We were just getting warmed up. Alexa, stop. Oh, well. Bare conductors usually use overhead lines. This was your ASTM. I don't think that's applicable. Nope. Solid versus stranded. I'm just looking. Yeah, there we go. So there was an article in IAEI News magazine that talked about fine stranded, and this would have been in the 2008 NEC. There was the section, it was the 2008 code. Remember I said I wasn't sure. It was 2008. They added that information about finely stranded. What does more finely stranded than class B and C mean? And I liked the article. Is this be replayed? Tom, great information. Is this, Willie? Yes. So this information is on the IAEI's YouTube site. So I am going to tell you that what you got to do is subscribe to the IAEI's YouTube channel. Okay, you got to do that. You got to click the bell. Don't lose this information. We need to get our numbers up. We need to get our registrations, our followers. It's free. And you get to see me on Tuesdays in the afternoon at 12 o'clock. What better way? You got Rudy. Rudy himself does the 10 at 10 at 10 at 10 at 10 at 10 at 10. And he talks about what's going on at the IAEI. There's a lot of stuff going on at IAEI. Don't miss a Rudy's 10 at 10 at 10 at 10 at 10 because you got to subscribe. So check it out, Willie. Hopefully we will see you on that YouTube channel. But this is finally stranded conductors. You'll see what it looks like. And you know, all I can say is finally stranded. You'll know it when you see it because it'll be a very flexible cord and it'll be a lot of strands, not like what you see over here. Excellent, Willie. Thank you. All right. So labels tell you how many strands. Look at this. You can't. Oh, let me get me out of here. Get me out of here. So look at that. So you got the strands, the stranded conductor there, and look what it says: stranded copper, 600 volt, 600 feet, 20 mils insulation, gasoline and oil resistant, internal wiring of appliances, rated 105. What was I thinking? Stranded copper VW1-1, 20 mils insulation. That doesn't tell you, does it? It doesn't tell you how many strands it is. It tells you a lot of other stuff that's important, but it's not going to tell you how many strands. And you don't want to tell your apprentices to count the strands, okay? That's not good. That would be a very bad joke. It's not on the labels. It's not on the insulation. There's a lot of other information there. Whoa, on that insulation. Look, what do you see on the insulation of these conductors? Diesel locomotive cable. You have EPR HVP 22 kV, 2 kV. You got TCFT4. You've got a lot of information in there. Does it tell you how many strands? No, it's not going to tell you. Right now, Chapter 9, Table 10, Conductor Stranding, gives you the conductor size and the number of strands. Excellent, Lou. Thanks for joining. We were just talking about whether or not we're going to ask you to count the number of strands on the next conductor that somebody gives you. Right? So there's a copper, there's aluminum, aluminum class B, there is the different size conductors, and they tell you the number of strands in each of those types of conductors. So Lou, you know, and Willie, when you guys get out on the job site, I want you counting those strands, you know, and then what you should do, because you can lose track, you should have those little tags you put around each little strand, and they'll have like numbers, okay? That's how we know you're doing your job. And remember, mind your strands, because if you do something like this, those strands are not under the conductor. Don't push them in. They're not supposed to mushroom around the terminal, the opening. Every one of those strands have to go in that hole. And Lou, Felix, you don't cut the strands off if it doesn't fit. Okay? If it doesn't fit, then that means you probably have the wrong size conductor. Go back to the manufacturer's instructions, they'll tell you. And some of these are not designed for stranded conductors, they're designed for solid conductors. Read the manufacturer's instructions. Failed terminals and cables. These are what happens. That glowing connection happens, and it will melt and meld right into the equipment. Section 1012 of UL 46AB requires a connector, a unit container, or an information sheet packed in the unit container for a connector tested with conductors other than Class B or C, stranding, shall also be marked with conductor class or classes of the number of strands. You don't haircut the wires. That's right, Felix. You don't trim the wires. No, there's no trimming. You're going to give it a flat top, right? I used to have a flat top. That's right. It's a military cut. 819, specimens shall be tested using both solid and stranded conductors for 30 to 10 odd conductor sizes and using stranded conductors for a number 8 and larger, unless the conductor is marked in accordance with 1013. So the UL 486 and all the UL standards give you, don't forget, subscribe. The standards will tell you how they're tested and then how they're supposed to be marked. The termination basics. There are 2 ends to every conductor. Read the manufacturer's instructions before you do your terminations. Look for those markings on the terminals. Torque, 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 torque. Remember, torque is important. Terminal markings may be abbreviated. So 75 degrees C, 7 may be used to represent a 75 degree C marking. A 9 might indicate a 90 degree C marking. Read instructions, Lou. We're electricians. We don't read instructions. That's right. We wait until the smoke comes out, or we go dumpster diving. I got to get a picture. I have a picture of somebody dumpster diving, but I didn't get his approval to use it. Although you can't see his face, all you see is his legs sticking out of the dumpster. But he was dumpster diving for instructions. For a connector marked for use with aluminum, with only aluminum, the single digit follows the letters. For example, AL7, that's a 75 degree C, or AL9 is a 90 degree C. So if you didn't know that, you do now. In place of the dash and marks such as ALCU or CUAL, for example, AL7CU would be aluminum, copper, 75 degree C. CU7AL, etc., 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 etc. Temperature ratings. Equipment may have special temperature requirements. Ampacity, 9 degree C conductor on a 75 degree C rated breaker terminal. Okay, but use 75 degree C ampacity of the conductor. Transformers. And I put this slide together. I'll tell you, I learned something the other day, and it was I'm working on a transformer educational piece. Yeah, Felix, when all else fails. And here's the thing. Here's what I learned. In my mind, I was thinking, okay, I've got a transformer. There's no overcurrent devices in this transformer. I can use 90 degree C conductor at 90 degree C ampacity. As long as what's on the other end is terminating on a 90 degree C lug and 90 degree C ampacity for the equipment. But here's what I learned. That when you have a transformer, some transformers, and it's in the standard this way, it will be marked that you have to use a 90 degree C conductor, and you can only use the 75 degree C ampacity column in 310-16. Now, what does that mean? That means that 90 degree C insulation has to be used because the temperature in that enclosure can get up high. And I need a 90 degree C insulated conductor, but I can only use it at 75 degrees C. I can't, in some cases, you might not be able to use or land a 75 degree C conductor used at 75 degrees C in a piece of equipment because the equipment instructions tell you it must be a 90 degree C insulated conductor. I didn't, you read about these things, but when I was looking at the transformer and I was looking at our instructions, and I'm like, wow, yeah, that's what it says. So those little details can be, the lug will be labeled 90 degrees, the equipment will be labeled, the transformer will be labeled with 90 degrees. But you can't use the 90 degree C column for ampacity. It's very rare that you will have a piece of equipment rated for 90 degrees C that you can use the 90 degree C conductor at 90 degree C ampacity. Keep that in mind. It's not about the overcurrent device. It's about the heat inside the enclosure. And it's about measuring the heat rise at the termination and other points within that piece of equipment. Use only in listed enclosures. Enclosures may have requirements in their labels. Read the label, RTL, right? And if the label is too small, you know what we do? I swear, and I work for a manufacturer, and I haven't been privy to these meetings, but I still say that manufacturers out there make the labels small for a reason, and I think it's because they invest in glasses and magnifying glasses. I'm telling you, I think that's the way that rolls. We already saw this one. Whoop, what's this say? What does this say? This says, this device accepts type GBK ground bars. Wire holes are suitable for 1, 14, 4, or up to 3, 14 to 10, number 14 to number 10 wire. So a single number 14 to 4, or 3 number 14 to 10 wires. Multiple wires in the same hole must be the same size and materials. So I can't do 2 different sizes under one terminal. I can't do 2 different materials under one terminal. We call those little golden nuggets of information. All right, how about this one? I can't even read what that says. We're going to try to get close. And even close, you know what? It's even blurrier. And the glasses don't make a difference either. What that's showing you is the wire size and the torque. That's what that's showing you. And fuse blocks and the neutral. And it just shows you that each of the terminals have torque values associated with them. And it says use 90 degree C wire. Hold on. Use copper wire only, except at terminals, and it gives you the terminal numbers. So not only it tells you it tells you to use copper wires, but it actually tells you exactly which terminal number that you can use something other than copper. Can't make this stuff up. I'm just saying. Well, that's a little bit better, right? It's the same one. So there's your wire sizes, and it says use 60, 75 degree C wire, use copper wire only, except at terminals N1 to N2, E1 to E2, T1, T2, ground and neutral connections. Consult the owner's manual for explanation of transfer system operation and features. Read the manuals. 90 degree C wire shall be used, and it shall be sized based upon the ampacity of wire 75 degrees C. So look at this one. So this, I think, this is field installed wiring. This is part of the UL standard. If the temperature rise exceeds 90 degrees on a terminal, as covered in item 9, a marking shall be provided near the terminal indicating that 90 degree C wire shall be used, and it shall be sized based upon the ampacity of the wire rated. So this again, it's just telling you that you've got to look for all the labels. Labels are important. The manufacturer's instructions are important. And if you thought you knew how to install something, think again. So torque, number of conductors, the type of conductors, the material of the conductors, how many you put on a lug, fine stranded versus regular stranding, all the different strandings that's in the annex material of the code. There's a lot of details associated with landing wires on terminations. And the point of my discussion today is the devil's in the details. And whoever is doing what we probably is arguably the most mundane task in an installation, terminating conductors, taking every one of those receptacles and putting a wire on these lugs, torquing them down, pushing it back into the box. all that jazz. Whoever's doing that job has to understand the importance of that job, because you don't want to have glowing connections. You want to make sure you're landing the right conductors on the right terminations, using the right torque and the right methods. It's important for electrical safety. It's important for the longevity of the installation. It's important for the homeowners, the structure, and everybody else involved who's going to utilize the electricity in that structure. So just when you thought you knew terminations, just when you thought it was easy, somebody had to go and rain on your parade. Go get your copy of the NEC. Go out there and make sure you are a member of the IAEI. Don't forget to subscribe and make a difference today and every day in electrical safety for the electrical industry. Thanks for tuning in for this hour of IAEI News Live. I enjoyed this discussion. I hope you did as well. Thanks for chatting it up. Send me some ideas on things you want to talk about, things you want to hear, people you want to see on the program. I got to start getting guests involved, and I'm going to reach out. I'm going to reach out to Peter Grazier, and I'm going to see if I can't get him talking aluminum, clad, copper clad aluminum, and let me know. All right, everybody. Thanks again. Felix, thank you. Thank you for joining in. Thanks, Michael Hofkin and everybody else out there in Tubeland. I really appreciate every one of you. Hey, Mr. Abbasi, thank you, Matt, for joining us very much. Matthew, you'll get I was just reviewing IEEE Electrical Safety Workshop, and Joel, rest his soul. I saw his picture on one of the papers. So I know you know Joel. I know you knew Joel. And Joel Sandel, and he was a good man. I miss him very much. We lost a lot of people during these COVID years, and in their memory. So they're up there watching. They're up there wiring electricity and designing systems. All right, everybody. Jody, thanks for joining in. James Thomas, thanks for joining in. Joe Bellantoni, awesome. See you at Supercode coming up. All right, everybody, take care, stay safe, and please remember, stay healthy. See you next Tuesday, right here. Subscribe.